Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Welcome back. Problem 9.15. So in this problem, it is given that knowing that beam AE is a 360 by 110 roll shaped and M0 is 310 kilonewton into meter. Length is equal to 2.4 meter, A is equal to 0.5 meter and E is 200 gigapascal. So you can see this is moment M0 at point B and M0 at point D. This is distance A. Total length of the beam is L. Clear, which is also given. So you have to find the equation of elastic curve for portion BD. So this is portion BD. This is portion. This is, let's say, point B, and this is G. So this is portion BD. So you have to find the equation of elastic curve and the point of deflection at point C. So you have to find this. So let's start with the given data. So in given data, we have beam AE. AE is W360 by 101 roll shaped. Clear. Also moment M0 is given as 310 kilonewton into meter. Length of the beam is given as 2.4 meter. This A distance is given as 0.5 meter and E is given as 200 gigapascal. Clear? So you have to determine equation of elastic curve. That is, you have to find y is equal to function of x for portion BD. And the second part is that deflection at point C. Deflection at point C, which is equal to YC. So you can see that due to this loading, the beam will bend like, it may bend like this. Clear? So you have to find the deflection of this point C at this. Clear? So this is YC. So let's start with the solution. So you can see that using continuity boundary condition at point B and symmetrical boundary condition at point C. So let me write it. Use continuity boundary condition at B and symmetry boundary condition at point C. Clear? So you can see from the equation, from your knowledge of statics, you can see there is no forces acting on this beam. So that's why RA is equal to RB, and that will be equal to 0 because there is no force acting on the beam. So as a result, resultant force are also 0. Clear? So we will move further and find the moment equation for the beam as well. So for first, when you section the beam at x is greater or equal to 0 and less or equal to A, so it means this is the portion. Clear? So at this portion you can see there is no reaction force and there is no moment at the beam. So at this point, at this range, x is greater than 0 and less or equal to A. So M will be equal to 0. Again, for this is the first section. In section 2, let's say between B and D, if you section the beam at this, so you can see there will be only, this is B point and this is C, so only these movements will be reaction movements, or you can see these movements will be available over here. So in this case the moment will be equal to m naught. Here the moment is 0, here moment is equal to m naught. This is section 2 and this is section 1. And the range for this section 2 is that x is greater than or equal to a and less or equal to L minus a, because you can see this is the x distance. It can be anywhere between B and D. Clear? So x should be greater than a and less than this. Total is L. Clear? So from here this will be L minus, this distance will be L minus a. Clear? This distance from this point. Okay. Now we know that this equation EI into d square y over dx square is equal to m, which is equal to 0. Clear? So integrating it once, I will write it EI into dy by dx will be equal to C1. Clear? Again integrating this equation, we will have EI into y is equal to C1x plus C2. Let this is equation number 1, this is equation number 2. Now here in section 2 we know that EI into d square y over dx, I am going to solve it simultaneously so that we move smoothly while solving our problem. It is equal to m and it is equal to m naught. Integrating it once, we will get EI into dy by dx is equal to m naught x plus C1. Again integrating it, we will get EI into y is equal to m naught x square, half of m naught x square, sorry, this will be C3 because C1 is here. So this, there is another constant of integration. So C3 into x plus C4. Let this is equation number 3 and this is equation number 4. This equation 1 is the equation for finding slope for range of the beam where x is greater than 0 and less or equal to a, and this is equation for finding the deflection for this range. Similarly, this is the equation of slope for this range. Clear? And this is the equation of slope for this range. Clear? Now we will move forward and we will solve to find out this constant of integration C1, C2, C3 and C4. So from this figure or diagram you can see that we have first boundary condition is that at x is equal to 0, y is equal to 0, and again at point A we have x is equal to a, y is equal to y, and at x is equal to a we have slope is dy by dx. Similarly, we will have another boundary condition, so you can see the slope at point C is this maximum slope. So at this point at x is equal to L by 2 we have slope is equal to 0. Theta C at this point is equal to 0, which is equal to dy C over dx. So we will use this boundary condition. So move moving toward first boundary condition at x is equal to 0, y is equal to 0. Clear? So you have to put in this equation in equation 2. So when you put this in equation 2, y will be equal to 0, x is equal to 0, so this term will be equal to 0. So it means that C2 is equal to 0. Okay, so we will use the second boundary condition, that is for x is equal to L by 2 dy by dx is equal to 0. Now the question is that we should use this 1R equation number 3. So definitely x is greater than L by 2, so it will be lies in this range. Clear? So we will put it in equation number 3. Clear? So when at x is equal to L by 2, dy by dx is equal to 0. So this term will be 0. Let me write it 0, and this is m0, and x will be equal to L by 2 plus C3. So it means that C3 is equal to minus 1 over 2 m0 into L. So up till now we have C2 value which is equal to 0 and C3 is equal to this one. We will find C1 and C4 as well. Clear? So what we will do that at x is equal to a, we have deflection is equal to y and slope is equal to dy by dx, which is equal to theta. Clear? So when you put x is equal to a, clear, in equation 1 and 2 as well as in equation 3 and 4, so you will see that the left hand side of equation 1 is equal to equation 3. Similarly, left hand side of equation 2 is equal to equation 4, and we will equate them also. Clear? So put x is equal to a, clear, in equation 1. So it is only C1, clear, and this equation 3. So it will be equal to m0 into a plus C3. Clear? And we know that C3 is equal to this value. So m0 into a minus 1 over 2 m0 into L. So C1 will be equal to minus m0. Take m0 as common, minus m0 as common. So it will be equal to 1 over 2 L minus A. Now you have C1 as well. Clear? So again, at x is equal to a, we have y. So put in equation 2 and 4 x is equal to a and equate them, as the left hand side of equation 2 and 3 are same. Clear? So I will put it C1 into a, C1 into C1 into a plus C2 is equal to 1 over 2 m0 x square. You can see this is m0 x square. So x is equal to a, so it will be m0 a square plus C3 a plus C4. Now you can see we have the value of C1, C2 and C3. So you can put it, I will put the value of C1 over here, and C1 is equal to minus M naught into 1 over 2 L minus A into this distance A, plus C2 is again 0. You can see I will write 0 is equal to 1 over 2 M naught A square plus C3. C3 is minus 1 over 2 M naught into L. So it will be minus 1 over 2 M naught into L A, and C4 is not known. So C4 is written like this. So when you solve this, you will get C4 is equal to half of M naught A square. This is C4. Now we have got C1, C2, C3 and C4. So you can put in equation 1, 2, 3 and 4. So you will get the desired equation of slope and deflection for x is greater than 0 and less or equal to a, and here equation 3 and 4 will give you the equation of slope and deflection for the portion of beam BC, that is x is greater than a and less or equal to L minus a. Sorry, this is BD, not BC. It will be BD. Okay, so let's move further in order to solve this equation. So as we are interested to find out the equation of elastic curve, that is y is a function of x for portion BD, for portion BD. Clear? So we will use this equation number 4 after putting C3 and C4. Clear? So when you put the value of I will also write x is greater than or equal to a and less or equal to L minus a. So this was the equation EI into y is equal to 1 over 2 M naught x square. Clear? This is 1 over 2 M naught x square plus C3 is minus 1 over 2 M naught L into x minus 1 over 2 M naught L into x plus C4, and C4 is half of M naught A square. Clear? Divide both sides by EI and take the common terms, so we will get M naught over 2EI into x square minus LX plus A square. Clear? So this is the equation of elastic curve for portion BD. This is our first part. Now we will move toward second part, that to find out the deflection at point C. Clear? Which mean at x is equal to L by 2. So here you will put x is equal to L by 2 in this equation. So y at point C will be equal to M naught over 2EI, and this will be L by 2 whole square minus L into L by 2 plus a square, and this will be equal to minus m naught. When you solve it and simplify it, if you are not able to carry on further, it's okay, you can stop over here. Clear? So m naught over ei into L square minus 4a square. This is YC. Now what we'll have to do is that we have given data. I will show you all the values are given, m naught, L, A, E, each and everything is given. We do not have the value of I only. So W360 by 101 roll shape is given at the appendix of book. W360 by 101, so it is 301. Clear? So you can write the value. All the value is given. I is equal to 301 or 301 here into 10 raised to power 6 meter 4 millimeter 4, or it will be equal to 301 into 10 raised to power minus 6 meter 4. So you have all these values, you have to put it here. I will put the value m naught minus m naught is okay. So I will go to above. M naught is 310 kilonewton into meter. 310 into 10 raised to power 3 divided by 8, and you have E and I. You have E, this, and I. When you multiply E with this I, so you will get 60 into 10 raised to power 6. Clear? You have L, which is equal to 2.4 whole square, and minus 4, and A is also given as 0.5 whole square. So you will get YC is equal to minus 3.05 into 10 raised to power minus 3 meter, or YC, which is deflection at point C, is equal to 3.05 millimeter, and negative sign shows that the deflection will be downward. I hope you have now clear idea about how to solve this type of problem regarding equation of elastic curve, or for finding the deflection as well as slope. Clear? Thank you for watching my videos, and do support me by sharing my videos with your friends as well.